Okay, picking up where we left off, and this was topic 7, and that's our special polynomials. We're going to just focus in on 2 of them that I want you to, and one is perfect squares. And in these, A and C of our trinomial are both perfect squares. So you'll recognize them: 1, 4, 9, 16, 25, 36, and so on. But, and this was a tricky thing with our topic 7 exit slip, is you have to make sure that that center term, that B value, adds up and makes sense, can be factored, that you can get 2 perfectly exactly the same factors out of it. So if we take a look at this, 25x squared minus 20x plus 4. I'm still going to go ahead and do my x, and I'm still going A times C and adding to B. So 25 times 4, 100x squared. In the bottom here, my B is negative 20x. I need 2 factors. I'm going ahead, I see it right away this time. I see that 10 times 10 is 100. And if I make those both negative, I can make them add to negative 20 and multiply to 100. So I have the same factor, and that's what you need. You need to have the exact same factor. So we're good there. We're still decomposing. 25x squared minus 10x. This time they're going to have to be exactly the same. Over here will be minus 10x plus 4. What are we taking out of here? What's our greatest common factor? They're both divisible by 5. So we'll go 5, and we need to grab that x. We can only grab 1. What's left? Now I'll stay with red. Inside is 5x, right? 5 times 5 is 25. X times x is x squared. Minus 2. Over here, negative 10x plus 4. Well, those are both divisible by 2. I'm going to make it negative 2 out here. Why? Because I want my inside binomials to be exactly the same. Okay, so I want 5x, and if I had made it positive 2, this would have had to be negative to get the negative 10x. But I want them to be exactly the same, so I have negative 2. So I have 5x inside. I'm going to have negative 2 for my plus 4. So negative 2 times negative 2 makes plus 4. So when we split this down into 2 binomials, we can see it's 5x minus 2 times that binomial that's exactly the same. Oh, look, those are exactly the same. So we actually want to write it like this: 5x minus 2 squared. People did great on that on the exit slip, for those of you who have completed it. Okay. Lastly, difference of squares. This was mostly done well, just some quick little things to tweak. So in a difference of squares, you're going to recognize it's not a trinomial. And I'll show you why in a second. And both are perfect squares. Both coefficients, or if it's a constant and a coefficient, they're both perfect squares. So if I look at this, 4x squared minus 16. Yep, you can see. The other thing is that this is always negative. Okay, and we'll take a look. If I can write small enough. So 4x squared minus 16. So I'm going to think about what the square root of these. 4 and 16, I know right away those are both perfect squares. The square root of 4x squared is going to be 2x. So if I think about this written squared, it's 2x squared. Take away what's the square root of 16, it's 4 squared. So now I'm going to split that into 2 binomials. So I have 2x and 2x. For this to be negative, one of these has to be negative, one of these has to be positive. And that's where I saw some people make mistakes. And you can check this. If you multiply this out, 2x times 2x is 4x squared. Good. 2x times 4 is 8x. Negative 4 times 2x is negative 8x. And negative 4 times 2x, negative 4 times 4 is negative 16. Since we have negative 8x and a positive 8x, these cancel each other out. And we simplify back to that 4x squared minus 16. So that's why this is called a difference of squares. We're removing kind of that middle term by them balancing out with the negatives. Okay, as always, send me your questions. Talk to me via Google Hangouts, wherever. I've had some successful Google Hangout phone conversations, some less successful. I will do my best to help you as best as I can with these questions. And I'll probably send some more examples of things throughout the week, but we will be working on just honing in on these skills and making sure we know which one to use when. Okay, take care, everyone. Bye-bye.